Welcome, data enthusiasts. We are Zuma, the recruitment agency focused 100% on data tech professionals in the Berlin region. And this is our podcast, Data for Good, connecting you with all things data. Today, we are joined by Fabian Schomm-von Auenmüller. Fabian comes from a strong background in data engineering. He's the head of data platform at AUTO1 Group. And as you probably know, Berliners, AUTO1 Group is a Berlin-based online car selling platform, a European giant. They've got a really strong data science, analytics, and engineering capability. And that's why we've got Fabian on today. Fabian, how's it going?
Hi, I'm doing fine. Thanks for having me. I'm excited.
Awesome. Okay, brilliant. So today's topic, a topic dear to you, I hope, I expect, is data observability. And given your engineering and platform background, I think you're in a great position to educate us today. So thank you.
Yeah, I hope I'm always happy to talk about what I do most. So thank you.
Cool. Yeah. Oh, good. All right. So data observability for people like myself and other or individual contributors across the data landscape, introduce this topic to us.
Well, the term itself, I actually not quite sure who or how it was coined. It's probably closely linked to Monte Carlo, the company who are building an entire product around the term. But it actually goes back a little bit further. So if you are working with data, you obviously need to make sure that you are monitoring the data. And then data observability is kind of the term to basically cover every aspect around that. So all the procedures from logging to monitoring to alerting to just making sure everything runs as a process. And that's kind of how the discipline got its name. And then over time, it has become more of a brand, I would say, where people can say, okay, yeah, I'm doing things in the data observability space, so that there's some recognition to the term, and then people know what they're talking about when they mention that term. So it's a bit of a loosely defined bag of terms and processes around data, monitoring and quality.
Interesting. And it's a whole data, as you've said, it's in terms of branding, it's a whole discipline in itself these days. Yeah. Well, why is it important? Why is it important to businesses generally, and why is it important to you in your work?
Yeah, so in my role at AUTO1, I'm responsible with my team for the data warehouse, where lots of data comes in and is then pulled out into reports, dashboards, and data science models every day, all the time. So we have lots of pipelines, and with lots of pipelines, you need to make sure that things are running well. And of course, you can, as a first step, you will rely on error messages and observe when things break. But you can't treat a data pipeline as a black box, right? You need to make sure that the data that is flowing through your pipelines adheres to the expectations that your data stakeholders might have on those data sets, right? And that's where then observability comes in. So it can start small. It can just be a quick data exploration, making sure this table is free of duplicates, for example. But in order to make that scale, you need to take that to the next level, right? You need to make sure that there are automated processes in place that regularly verify these assumptions and these, you could even call them rules that you place on your data to make sure that, well, data quality is met, right? And nothing flies under your radar, if you will.
Okay, interesting. And I wanted to, my next question was going to be, at what point should data teams start caring and investing in this? But maybe before that, I should ask, what is the investment that a business needs to make to implement data observability?
Well, it depends really on your use case. I mean, there are different levels where you could plug that in. So for example, if you load your data in batches, then it makes sense to check your data once you have processed a batch. But if you have a streaming pipeline, then it's different, right? Then you need to find a different granularity. So in terms of investment, it's actually fairly low, depending on what you do. So there are open source solutions out there that can help you set this up in a more declarative manner, so you don't need to reinvent the wheel. So the investment is probably more on the time and organizational side of things, which kind of ties over into your next question. When should teams start doing that? As soon as possible, or as early as possible, I would say. It's kind of like software engineering, where you need to test your software, right? That's how you build proper software. So think of data observability or data quality checks as data testing. Now, it's not as strict and not as clearly defined as a discipline as software engineering testing is, but that shouldn't be an excuse, right? So verifying all your assumptions and making sure your data quality is up to snuff, that's something that you can start from day one, really. So the very first pipeline that you build, or the very first dashboard that you build, it should be built on high quality data, and you should make sure that the data quality is not just on day one as it should be, but that it continues being high quality. And I'm saying this because data is quite dynamic, right? So data changes and evolves, right? So as the business grows, so does the data. And when the data grows, then things need to be adapted, right? Schemas need to be changed. And then your pipeline might not produce the same results as it did when you created it first, right? So you need to be up to date, and you need to make sure that your pipeline is also up to date. And when things go wrong, and they inevitably will be, then you need to make sure as a data engineer to be the first to know, because nothing is worse than some analyst coming to you and saying, oh, something broke, or this number can't be right, or we don't get updated data here, and then they inform you about the problem. You want to be in control, and you want to be the first to know when things break. And that's where data observability helps, because it gives you the tools and the processes and the techniques to really make sure that you are the first to get that alert, and then you can react to that, ideally before worse things happen downstream.
Okay, thank you for that. You by default suggested that it would be the data engineer that would be doing this. Could you make it clear to us who takes accountability for data observability, and who else can be involved directly or indirectly?
Yeah, that's a great question, because I'm not sure if there's a right answer to that, because it could be many different people depending on your organizational setup. So I'm saying the data engineer because the way we work at AUTO1 is that we have a central data engineering team that is responsible for ingesting and loading all data into one central data warehouse, which is then the single point of truth. Now, if you have a more dedicated or spread out setup, that might be different, but I'm talking about the AUTO1 setup here. So as we do have this central team, and we are owning centrally all the data ingestion pipelines, I would say it is the data engineer's responsibility to then make sure that those pipelines are then working as expected. The problem then comes when you do find a data quality issue through your observability tools. What will you do then, right? And then it becomes the question of who's the owner of the data, which is probably usually somebody upstream, right? That might be a third-party app, or another service, or an internal database. It could be anything. And then it's a bit more tricky, because then you need to make sure that those upstream data producers are aware of that and can fix that, or if they can't fix it, then somebody needs to, right? So it gets a bit more tricky. But at least you're on the case then, right? So knowing is already half the bill there. So that's where it then starts.
Okay, thanks for that. It might sound obvious given the topics of best practice and quality, but break it down for us. What are the benefits for the... I'm thinking of data engineers, if they are to invest their time in this, if they're pushed to invest, or they want to do it voluntarily, what would be the benefits to them in their activities, in their job, if they are to hold these data observability standards?
So as it usually goes, the sooner you find and solve a problem, the better, right? So for example, when you are pushing some new code, if you catch the error before you commit that code, then no harm was done and you can still fix that. But if you find a problem when it has already been published in some dashboard, then it might have already been used to make a decision maybe on the wrong databases, and that's much more harder to rectify. So when you think of that data lifecycle, it's usually best to catch things as early as possible, right? And ideally that would even be before it hits the data pipelines on the producer side. But if you're not in control of that, then the first thing that you can do is basically check the pipelines, or rather check the output of your pipelines as soon as they ran. So in our case, we do have a lot of daily pipelines, and we run them usually during the night. And as soon as those pipelines complete, we then run a couple of data quality checks, right? Are all the assumptions valid? Are all the primary keys unique? Is the last timestamp what we expect? So we define that for every table individually, so to make sure that every table is updated as frequently as we expect it to be. And the benefit then is when you catch things early, you can easily rectify them. And if you catch them later, then you might need to run behind. Okay, which of my reports used that data point? It's wrong. And then you might need to catch your stakeholders and say, no, don't trust that report. Don't trust that dashboard. It might be wrong for whatever reason. You might need to rerun stuff during the day, which you usually don't want to do, and so on. So yes, it is a bit of an initial commitment to do that, but it will pay off more than 10 times over in the long run, because then your pipeline is more robust, it's more flexible, and most importantly, you will build up trust, because trust is something that you need to really build up carefully each day, and you can lose that in another day if you're not careful. So trust in the quality of your data. If you lose the trust, then you might not get any other how do I say this? Losing trust is the worst that could happen to you, right? Because building the single point of truth it's based on trust. So making sure that this trust is well placed in your data, in your architecture, that's super important. And the pipeline monitoring, the observability, it just gives you that much more confidence in being able to live up to that level of expectation and then to maintain that trust.
It seems like the benefits are boundless for both the individual contributor, the data engineer or whoever it is, as well as the upstream stakeholders or whoever needs to use and consume this data. Okay. With that, you mentioned when code is pushed through pipelines, there are daily data quality checks that go on. I wonder, do you have a methodology or an approach to kind of either implementing or maintaining data observability? Is there like a best practice you would follow?
I mean, we are learning this ourselves as we go, but what worked well in the beginning, especially if you have not that many resources to commit, is it's similar to regression testing. So when you are faced with a problem, then you check, did we have a test for that? If not, then add one. So based on the incidents that you had in the past, add checks and tests that allow you to identify similar cases in the future, because it's very likely that they will repeat. Also, not all your tables and all your databases are similarly important. So there might be data quality issues elsewhere where it doesn't really matter that much. So you have to remain focused on what's important for the business, what is critical for your stakeholders, and where do I get the most complaints. So that's usually a good starting point, because that's where the business makes its money from, and that's where this added level of confidence through tests and observability gives you that boost that you really need. And then you can start from there. And then once you do have more, maybe a more rigorous testing strategy or a better tool in place, then you can start rolling that out. But another piece of advice here is don't overdo it just for the sake of it, right? I mean, reaching that 100% test coverage, that's always great. But typically there's also a cost associated with those tests, and not just in setting them up, that's usually just a one-time thing, but also if your tests are run as a query against the data warehouse, for example, then that query itself could have some cost. So to give an example, we do have a very large log table which has a unique ID column, and we absolutely want to make sure that we don't have duplicates in that log table. But it is very, very large. I think it has over 10 billion rows by now. So just doing a quick select which checks for duplicates, it's quite expensive. So what we have done for this table specifically is that we are just checking for the last X days, right? And then just as a window, we only check the last days. And as we do that every day, we're pretty sure that yes, we have once checked the past, right? And then every day we only check the last X days to make that more efficient, right? So don't overdo your testing if it consumes your real world resources, because otherwise your cloud bill might explode, and that's usually also not what you want.
Interesting. It sounds like the approach can be somewhat reactive, or at least learning from past mistakes to predict future outcomes, and also to be mindful of budgeting or costing as you go along the data observability path. I wonder, you mentioned at the beginning Monte Carlo, perhaps data observability, or at least the terminology comes from them as a product platform. What tools would be involved for the average data engineer, or what tools could you recommend for upkeeping or maintaining data observability?
So from my own experience, I have made good experiences with Elementary. So Elementary, it's custom built for DBT essentially. So it really plugs in and integrates great with DBT. And it's also open source, which is why we started using that. So it has very low barrier of entry. So if you have a DBT project and if you have some tests in DBT already, then adding Elementary on top of that and just adding that, it's a very easy tool. So it gives you a dashboard of all your DBT tests. And the nice thing is that dashboard can be shared easily with the stakeholders because it's just one page, right? It's really easy to understand. So it gives you some nice graphs, green and red for things that fail and so on. So that works well. It doesn't have the full-fledged features that a more sophisticated observability platform would give you. But if budget is a concern and also time to roll out is a concern, then that is a good first step to demonstrate what it can do and what it could mean. There's also another tool which is up and coming, which is sync.io, which I think they're still quite early in their development stage, but so far from what I've seen, it seems promising, and they try to position themselves as a competitor to Monte Carlo. So
Open source?
I don't think so, not yet at least. It's not open source, but they try to enter the market. So I think I'm not sure what the exact pricing model is. But from what I've seen and from what I've heard, it looks interesting. So I'm really excited to see the observability space and the market grow over time, and I can't wait to see what it will bring over the years.
It sounds like you have quite an established practice of data observability at AUTO1. I'm wondering if there might be learnings for other people, learnings for other teams and businesses in implementing and investing in data observabilities. What have been your mistakes and your learnings from them? What might you do differently if you were starting the journey again?
Mistake would have been to not start earlier. So looking back, I think if we would have done this from the start, as I had just said right earlier, then I think we would have been in a better place, or rather we could have avoided some of the more severe incidents. So, and when I say incidents, people think like, yeah, well, the data is wrong. What could be so bad about it? And as a data engineer, you might look at the data and think, yeah, let's fix that or not fix that. That's an issue, and that might not be an issue. But you always have to be mindful of the business that is behind what you are producing as data, right? what I'm going to say is it can spiral very quickly, to not be careful at one place and then have tremendous exponential effects downstream that can affect your business entirely. And I'm not even talking about the potential, the trust issues or the reputational damage. If our customers and merchants don't get their documents for their cars, for example, quickly, then that can quickly become a more severe problem than you would anticipate. So being on top of your data game, testing early, starting early, that's definitely one thing. There's a famous quote, truth is good, but control is better. So I thought of that when I was preparing for this interview. And I think that that's true because yes, you should trust your data, but controlling that through explicit tests is better. So again, to give an example, when you assume that something is unique and without duplicates, yes, you can trust that, but still put a check there, right? Because at some point something will break, right? And then you will have a problem. But having a test will alert you as soon as possible about that. So the recommendation here, the best practice is explicate your assumptions, make sure that you talk to your stakeholders, make sure you know which tables are most important for the business, where's the criticality, and then add explicit tests on top of that and make sure that when those tests fail, you are the first to know and you are the first then to fix that. So explicating assumptions, expecting failure is another thing that I would say is a learning. So usually you trust your own code, you trust your own pipelines, but don't expect things to never fail, right? So have a process in place that when this breaks, what will happen, right? So if you are in a position to have the time to do it, do an assessment, a risk assessment. What will happen if X, Y, or Z breaks, right? And by breaking, I mean a server outage or some network connectivity issues, right? Anything could happen. So be aware of your most critical pieces of infrastructure and then have monitoring and alerting on top of them to make sure that when things go wrong, you know what to fix first, you know about priorities and so on. And that then ties into my last piece of recommendation, build idempotent data pipelines. So idempotent means that a data pipeline can be rerun as often as you want without actually changing the output, without introducing duplicates, so that when things do go wrong and you're not the first on site, but somebody else might be there, they can restart the jobs, they can rerun the scripts without actually jeopardizing the state of the data in your data warehouse. So that's usually good design. That's what's preached, in every data engineering course. Do take that advice to heart, is what I say, because if not immediately, but later on, people will thank you for keeping that in mind and will thank you for building robust data pipelines that don't make a mess if they need to be rerun or if they don't run for a day. And then, if they can auto catch up, for example, that's always better than if you need to, fudge things manually on the database.
This is fantastic. So your learnings really have set some best practices or some ideas for teams to follow in the future. So I call explication of assumptions. So explicate assumptions, expect failures, and have a process on how to react to those failures. Build idempotent pipelines to ensure best practice. That's your 3-point best practice, straight from the horse's mouth. Thank you for that, Fabian. I wonder if this is something that is undeniable. Every team should be investing in data observability. How do you see this area evolving? What do you think the future trends are for data observability?
Oh, that's hard to say. I mean, the data observability is closely tied to your data stack, right? So if you are operating on a data warehouse, you might, run things as a SQL test, for example. But there is a shift towards more, decoupling between compute and storage, and also preventing vendor lock-ins, and a more liberal, democratized setup, which is commonly referred to as the data lakehouse, right? Where you just store your data in an object storage, and then have your query engines on top of that, which then can connect to that with some metadata layer in between. So if you're operating on a data lakehouse, it might look different, because you might not be able to just as easily run your tests, or you might have different pipelines, right? We touched on batch versus stream in the beginning. It might also depend on your data format. So for example, we are mostly concerned with relational, hard structured data. But if you might be operating on semi-structured data or even unstructured data, then it might look completely different what you want to do there, right? It's really hard to say, but I would expect that maybe even I will put it here. I would maybe expect that AI might play a role in learning patterns of your data, and then raise alerts when those patterns are not matched. And then the nice thing about AI is that you can prepare for your unknown unknowns, right? So the things that you do not know can go wrong can still be caught by a trained algorithm without your manual intervention, right? So in the beginning, I mentioned that, yeah, you can do regression testing where you add checks for the things that had failed, right? And that's good, but you want to prevent things from failing in the first place even, right? So maybe AI might play a bigger role here. Maybe some cool machine learning algorithms will make this even better in the future. I mean, there are already quite some applications for that. So for example, anomaly detections, when row counts are out of bounds, when one day you get double the data from previous days, right? That might be an anomaly that is already easy to detect by a system that is set up to detect those things. But I would expect that more development in this area will make things even more easy to use, easier to plug in, and then give you those alerts that you might not even have thought of, and maybe some of them are then false positives, but maybe the algorithm can even learn like your preferences. So there's probably lots of things that can happen on that space in the future. But again, don't lose context, don't lose sight of your business. Make sure that you don't jump into these technologies just because the AI hype is real. Make sure that you are delivering some real value to your business by providing that high quality, trustable data that you are you might be hired to provide.
Fantastic. I feel like this is only bite size. It's only the beginning of this type of conversation, but I love your enthusiasm for this topic, especially when it relates to the highest quality of data practices. So yeah, I really appreciate it. Unfortunately, it's all we've got time for today. I suspect if others have questions, which they will, they should reach out to you directly. I think LinkedIn is probably the best option.
Sure.
And people can also reach out to me if indirect is preferred. But yeah, I just want to thank you for today. Great area of insight for the Data for Good podcast. And we look forward to having you on again at some point.
I'd be delighted to. Thank you.
Sweet. Okay. See you all next time. And Fabian, I'll see you very soon as well. Thank you.